So, hello, we are going to do Codeforces Round 1838 uh, with 877, 1838 as so let's see. So, well, something, oh, something painful happened, I guess. The two integers were written on the blackboard. After that, the following instructions carried out n minus 2 times. So, they kind two integers on the board and write the absolute value of their difference on the board. After this process was complete, the list of n integers was shuffled. You are given the final list. Recover one of the two numbers. You do not need to recover other one. Okay, so two integers were written on the board. After that, the following step was carried out. Any two integers on the board and write the absolute value of their difference on the board. Okay, so the maximum values will always be one of the values, or if there is any negative value. Because if negative value was there, then my maximum value, new maximum value should have been created. So here, hmm, it's sad. It's sad. And then, hmm, begin. Okay. करना I guess. So I think opening terminal will is pain like that. So I think we'll have to do like okay. I guess I will have to do it like this. Hmm. Okay. Okay. I guess we will be having a full screen. Okay. Now it seems better. 2000. Okay. So there will be only one negative number if there was any negative number. So we will pick that. Otherwise, we will pick one number. Otherwise, we'll pick maximum number because maximum number should have been there from the start if negative was not there. You are given a permutation P of size n. You want to exactly minimize the number of subarrays of P that are permutations. In order to do so, on the following operation exactly one. Select I comma j, then swap pi comma pj. For example, we choose I is equals to this equals to the resulting array between 5, 4, 1, 2, 3. The number of subarrays of the permutation. If there are multiple answers, print any of them. Okay. Well, the point is if there already is a permutation. So, okay, so we just have to choose I comma j. Anyways, if we had to answer 1 or 0, we would just check that if this was already not sorted. But now what we can do is we can send 1 to the last position or n to the first position. Anything will do. So, okay, and then e dot begin, comma e dot end. Okay, so if I'm doing that, then begin plus 1. Okay, so order doesn't really matter anyway. Okay, n is not at the first place in any of the positions. Interesting. Well, we need to minimize the number of subarrays of P that are permutations. Okay, minimize the number of subarrays of P that are permutations. Okay, so what I want to do is I want to bring n between 1 and 2. Okay, so this seems much better. So 2, 1, and n. Okay, so if n is already in the middle, then what I will do is I will just pick n and put it in its own position. Otherwise, I will swap n with 1 because n will either be on this side, if this was on this side, n will be on this side. Okay, if n is on this side, then I will swap with 2. Okay, and n is 3 they are given. They are so, matlab, that is so sweet of them. Luto. Well, I don't really care. 1, 2, and 2. I can treat both of them as same, 1 and 2, because I want to swap n to the closest one. If n is equal to them, then it is here. Okay, I can just pick any two numbers. These are the three main cases. Okay, so I should do return, return, return. Yes, right. Just in case if like this should not happen because one of them should be true. 2 comma 3. Okay. 3 1 comma 1. Okay, interesting. 3 comma 4. Yes, this should happen. And 5 comma here 2 comma 4. 4 comma 3. What? Oh, this should not be 4 comma 3. This should be 2 comma 4. Is it the student area? This is for test case. Here I'm saying 4 comma 3. Interesting because saying 4 comma 3. Oh, n is 6. I'm thinking n is 5. Dumb of me. This should be correct, right? Yeah, it is correct. You are given n and m. Fill n by n grid with the integers from 1 through n to m in such a way that for no two adjacent cells in the grid, the absolute difference of the values in those cells is not a prime number. Consider just if they share a side. It can be shown that the under there is always a solution. Such a way that for any two adjacent cells in the grid, the absolute difference of the values in these cells is not a prime number. Okay. Well, we can always do if n is not prime and m is not prime, then we can put values this way. But uh, okay, if I put values like this will be like difference of 1, 4, 5, 7, 8. Is that correct? Okay, so n and m are greater than 4. I don't have to worry about 4. Anyways, okay, 4, 3, 4, 5. Hmm. So I will put it from the bigger side always. So it will be okay. Okay, seems good enough. So idea comes around like this. So suppose we have four, then multiple will be four. Okay, but if we don't have four, we have something like five or six. So we will put something like this: one, then leave this open, then two, then leave this open, then three. Then we will put four here, then we will put five here. So the and all the numbers. So what I mean by one, two, three, four, five here is basically this will be one into one plus uh one into one plus one into one plus zero plus one till m minus one, something like that. Okay. With four, there will be a problem if a row is a prime, but we will always choose the bigger side to fill. We will fill the bigger side like this: one, two, three, four. If the columns are bigger, then we will fill them this way. Okay. We can always just reverse them again then, because that is always possible. So construction code might become a little pain in the ass. So, but we'll see. Well, it should not be that bad still. Okay. So what I'm here is goal default if less than swap n and reverse is equal to true. So now we will use this reverse variable when we will have to put the values again. Okay, so I plus I is equals to x, I plus is equals to 2, and then we'll put for and j is equals to 0, j less than m, j plus plus, valor I j is equals to count times m plus j. This should be it, right? Okay, times m plus j plus 1. And we'll do here plus is equals to 2. Come on, hmm, just do here. If vector in of n 0 I less than I j plus j n j plus plus h of j of 5 is equals to val of 5. Then we will say value of h 0 I less than n. I j plus m. Okay, so this comes out to be shit. What and I is equals oh I forgot to put that. Okay. I don't even want to somehow look at this. 9, 5. This will be 4. Okay, so this was where I did reverse because certain issues, and this will be extend to something always. So should be good enough. If it is passed. So there are less submissions, even though it has been a time, quite a time. So we started late, but we are on right track, I guess. Bracket. Bruh. Who comes up with these statements? There is string as of length and consisting of characters this and this. You are walking on the string. You start by standing on top of the first character of S, and you want to make a sequence of moves such that you end the nth character. In one step, you can move one space to the left if you are not standing on the first character, or one space to the right if you are not standing on the last character. So you may not stay in the same place. However, you may visit any character, including the first and last character, a number of times. Each point in time, you write down the character you are currently on. String is walkable if there exists some sequence of moves that take you from first character to last character such that the string you write down is regular bracket subsequence. Okay. Interesting moves. Well, first of all, the number of moves will always be even because will always be with same parity as n minus 1. So n minus 1, if n minus 1 is like what is q queries from value this to this, so flip the values of this to this vice versa. Okay. Okay. Here n 10 also odd, even though it is still walkable. Hmm. Interesting. Hmm. First example, after the first flip, the string becomes this 9. Oh, okay. Okay, so we will write first character always. We have to answer in yes or no. Hmm. Can we accumulate enough of this initially to go there later? So we have there are so the last position of this. After this, there should be a regular bracket subsequence, if possible. This should be okay. This should there some should be zero after this, and before this some should be zero. If there are two such elements such like this, okay, then we can just do many repetitive moves here. Come here, many repetitive moves here, and if n was odd, the answer will always be no because there are not. We will have always odd number of odd characters in front of us. So I don't care anything in between. My answer should be yes or no anyways only. So if n is odd, all the queries will be no. But if n is even, I want to just keep track of these characters. And the sum before me should be zero, sum after me should be zero. Okay. If I induce I here, okay, I think this should be possible. don't know anything else. So let's try to code it, but it seems hard. Mhm. Or should positive plus x. If there is no such thing like this, if both of these are present, then I can just do something like yes. First this and last this will determine whether I will have balanced sequence or not. If this is not present, then after this, a sum should have been zero or positive. Well, some could not be positive because there was no. Some could be positive plus one, something like that, maybe. Well, if it was plus, no, it could not be positive because then this bracket would have been there. Then so this should be zero and this should be zero. This should be non-negative. Okay. Okay. Simply, if this is before that, then answer is impossible. Now we have made it a bit more simpler. Now if this is not anywhere and this is not anywhere, then the entire sum should be zero. Okay. If this is not possible, then I should have some. Okay. So if this, if one of them is here and the other is not here, then will we ever be able to balance this thing out? No. So answer will be no. If both of them are not here, then answer will be yes. It seems pretty good. If both of them are not here, so basically my sequence is this, which is always good if n is even. It dot update I comma 1 else it dot update I comma minus. This should be I. It dot update I comma minus 2. Second, open, close. Desktop files and dot erase page and okay. And -1. Erase. Okay. This is equal to oh here. I'll close dot insert page -1. Insert page. Okay. So the update is done. If is and continue and reading. What are we And n is even, n minus or become current or runtime error maybe. So wrong answer. Seventh. I change the seventh character. Then I get this, 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 six, this, this, this. This should it is. Okay. Version. Yes. Yes, I will say yes. Then I didn't even come here. Oh, I'm done, bro. I didn't even put initial there. So I used to. Mm, I'm worried that it might be wrong. Maybe it might be wrong. Okay, so well, let's just see if it is wrong or correct. Well, let's just take it. Okay, it is wrong. Only 40 submissions. Too low for the amount of time that it has passed. For the amount of time that has passed. Okay. Will might try E later, but we'll have to see. Open dot begin is less than star close dot begin, and open dot r begin is less than star close dot r begin. Okay. Star open dot begin and one XOR one, but r begin and one XOR one. And my timeline should be all. Yeah, I'm putting this thing. This is odd, even odd. This should be odd. This should not be odd. This is good. This, this is odd. Then this is bad. Oh, we don't actually have to check about parity. Some after me should not be the case. Begin. And then zero. One, two, second, two, one, yeah. That was not declared in this. Oh, zero patient exchange. That is okay. Bracket. I think this should be enough or not or not. We are looking close to it. Okay, people. This should be enough according to what I think, but might still be wrong. Oh, as expected, this is wrong. We'll look at E now. You are given an array of somewhere or element AI lines instances. Okay, how many different arrays C of M integers element VI lines range 1 to 3 and age is subsequence. Considered different if they differ in at least one position. Y if X can be obtained from Y by a deletion of several, possibly zero elements. Hmm. Quite a big M, and quite a big K. M की power. These are not even distinct. So quite a hard problem. Seems to be. If they were distinct, the problem would be something else. Then I miss this. Yeah. Hmm. Choose for distinct for distinct array it should be a little more possible. For same elements, this is a complete disaster. I have a better chance of solving this. Queries. Okay. only one of the pairs appear, then the answer will always be no. If none of them appear, answer will always be yes. Is that so? No. Now it will always be yes in this case. Okay, so this should be correct, maybe. And if two brackets appear like this and like that, then this will be yes if this sum is greater than equal to 0 and that sum is less than equal to 0. Then, because I would have managed the amount of positive and negatives properly. This yes. In the middle, anything goes. I don't really care. Was that the only case that I was missing? That the first element can be this and this. Hmm. I don't even know brute force for this problem, anyways. Like, what is brute force for? What will be brute force like for this problem? Okay, we are failing the larger cases now. I see this as a complete win. Less than equal to 0 and hmm. So what am I failing now? Position minus minus. That's a odd. I won't be moving back and forth at regular bracket sequences, right? In the middle, anything goes. Oh, again, no. Okay, so this is that and that. Okay, so this should never happen because otherwise I would need two more closing brackets. That would be the R begin. Bit dot update position comma 2. Close. Why is this so much painful to look at? Add the binary arrays of ones and zeros. Ah, okay. Mhm. I like that. That's so funny. Mm. And they are the same conditions at the end of the day. But if these conditions fail, let's try. Let's try to check that we are maintaining this list properly or not. Mm. So we will be maintaining this properly. Mm. 5 for example. Mm. 0, 0, 0. Okay, we don't have to. Okay. Hmm. Well, I'm just checking right now that my open and closed lists are maintained properly or not. Seems they are. So I should not submit this many times. Hmm. This should also be wrong. This should not be correct. What the fuck? Like, why is this wrong then? We never know what happens with my code. Only God knows my code. This should be. Damn. I legit don't know what is wrong. What was wrong with the previous code? Let's just now look at it. There are zero submissions on that. Crazy. Huh. Seems combinatorics. And I don't have a like really great experience with combinatorics. Oh, k to the power m minus n times m choose n. But now this is a little different. And so how about this? Here I can put anything except the next element. Okay, so this will allow me a great deal. So I can here put any number except the largest number. Okay, so if I have k1 elements and I have m minus 1 choices here and I have m choices at the last. Okay, so this will come out to be if I put k1 element here and I have m minus 1 choices, then it will be m minus 1 की power k1. Something like that. K1 m minus 1 m minus 1 m minus 1 m minus 1 की power k1. Nice. Now, If m is equals to 1, answer will be 1 because n will be greater than 1. If k is equals to 1, answer will always be 1. So we can always first do that. Now we are k1, so we have 1 plus m minus 1 x n plus square x square until okay. So I have one upon this at the power n times 1 upon this mx. Now this I want to find coefficient of x the power m minus n here. Okay, so it will be m times it would be a this place here n plus r minus 1 cn. So this will be r times this c1 m power r 1. Okay, okay. So we have m की power 1 m power 0 times I want to look at a star and the algorithm. I want to take a look at formula again. So this brought me to main page. N plus k minus 1 cn if there are an identical operation to k level box. ठीक है. Okay, so we have n equals 0 and minus 1 की power capital K. Let's say capital K, which will be here small n minus n capital K times, and this whole thing will be I because it will be choose I minus 1. or I choose 1. Here n is 1, k is 0 when I'm not putting any elements here. When, when m is 1, 1 plus 1 minus 1, 1, 3, 1 times m minus 1 to the power k times minus n cn. K plus n minus 1. Okay, I did k minus 2. So minus 2 chosen k x chosen minus x chosen. Here it is 3, 4, and 2. Oh, why is this so bad? If m was small, it would have been quite delightful. If n was like 10, even 10 to the power 6 would have been delightful. Time x is x to the power 10. So this allows me to upgrade the, and here suppose I use coefficient of 0 for 0 here, which is just 1. Just 2 or 1 is m, 2 is m square. Okay, so this will just be ncn. Okay, so this is for x is n minus x minus 1 choose n or k minus 6 minus 1 n minus 1 to the power k minus 6. If I this will be x choose x hmm, minus 1 to the power of k minus 6. Yeah, this seems reasonable. We put x is equals to 0 here for this x equal to 0, then we get x is equals to 0. My solution is not depending on AI any like this seems that's like really bad. This seems really bad. x is equals to 0, we get n to the power 0, 1, 1. And we put 1 here, then we get k was, oh, this should be k to the power of x. This should be k minus 1. So this turns out to be m plus n minus x. And this was m minus n, I guess. Yeah. This will be m minus n plus n minus x. So m minus x minus 1. Choose k minus x minus 1. Choose n. This will be, yeah, here just put plus n. K minus 1. Like we are trying to create some formula here, but for 0 we put this, and when we put it here, we get m minus n is 1 plus n minus 1 p n. N is 3, right? But number of elements is only 1. It doesn't really matter. Okay. Oh, this is n minus n. And this is yes, n plus n minus n. M minus 1 cm minus n, which is, turns out to be m minus 1 is 3 c1, which is 3 times m minus 1 power k minus 1 power m, like this thing, which is m minus n minus x. M minus n minus x as plus 0, then we get 3 into 2, which gives us uh, next is 4, 6 plus 4, we 10. Maybe just get 10 as answer, and it is not even close to answer. Answer was 9. Idea is to avoid repetition. So suppose I am 4 and I put some elements here. If this was subsequence before me, this was subsequence after me, and I put 4 here. Then I won't count this 4 as my standpoint. I will count this one. So anytime I will only pick standpoints as the leftmost occurrence after the this element. Then the leftmost occurrence of 4 here again. Then the leftmost occurrence of 4 here. Something like that. This 3 can occur multiple times, but this 4 cannot occur multiple times. So I came up with the formula that here I will put some x1 elements. Here I will put some x2 elements, then xn elements. Then I will put x of n plus 1 elements. So I here I can put any elements. So this will have all elements have m choices. Here there are m minus 1 choices. There are m minus 1 choices. There are m minus 1 choices. Okay. So this will turn out to be 1 plus m minus 1 times x plus m minus 1 times x square. And square times x square. Similarly, this to the power of 3 times 1 plus mx. This will be 1 of x, which will go here and come here. This turns out to be m plus times m minus 1, which is which is not even close to the answer. Hmm. 3 times m minus times what is the answer? Answer was 3 times k minus. I'm sorry here. This is capital K. This is capital K. This is capital K. I wasn't dices. I forget every time. 1 plus kx. 3 times k minus 1 of x time plus k of x. I'm trying to uniquely determine it by the leftmost first occurrence of the subsequence, and then I'm just fixing the first occurrence of the subsequence, this given subsequence. But not turning out too great, which feels really bad, honestly. 1079. So the answer for this is 1079. 9, 11383, 1079. I thought if it is some multiple of 49, then I can just take k minus 1 because k was 8 here. 7 minus 5 was 2. Then k minus 1 to the power of 2 times some factor, some value of combinatorics. But that doesn't seem to be the case. Hmm. Okay, so this one here I have only one choice. Here I have two choices. So 1 upon inspect on 1 minus 2. Power 9. Then we get e power 9 plus power 8. Hmm. It seems to be working here. Then in 10 comma m comma q tn. Okay. Okay. And then we have values of a Yes. Mm, mm, five comma n 5 and 9. At least one of them got correct. And this got 6. Pretty interesting, honestly. So this got 5. Okay, so that was 5, 3, and minus and minus. Mm, that's why. So my formula is apparently correct. But like, how do I minimize this formula into something better? So here I want to write here it is as use of n minus n minus I plus n minus 1 comma n minus 1. Okay, so I can put out this I n n plus n 1 times n minus 1 0 0 0 I and here we go. Jesus. 1900791053. Let's just try on this. If only m was even 10 ki power 8, I could have done this. Man, this is so frustrating. Uh, Now I have to like derive some formula from this, which I don't even know if it exists or not. Minus I minus sun, and here it will be mm, I minus I, uh, mm, m minus n minus I. One plus any better way to visualize this thing? Any convolutional way, like this is a convolution of two different series, then we can get one specific answer. I don't know. How did we get five here? It's a chaos. Three. Got two and this got three. Okay. That's this. 143. Okay, so I think I am writing something else. I comma I. Okay. I have like big of M solution for this problem, but I don't have anything better. There are very few solutions on this problem. Anyways, I think there should be a way to convert this. It's just I don't understand that way. Quite complicated, not gonna lie. Um, Okay. We take this polynomial. A in this. Then we take this polynomial. Yes, given expression is x squared multiplied by a 2x. Then we get this coefficient of x to the power this one. We will get this and plus given x. Mm, that is definitely not it. When I equals to plus x to the power n. 1 plus x to the power n minus n given x 1 minus. So this is given x power. Mm, So I have a formula, but I'm not sure about that. My answer will be coefficient of x to the power m minus n in this equation. 1 plus x to the power n minus 1 by k1x times by k1x and by and multiplying 1 minus k2x. Here k1x is equals to k minus 1 and k2 is equal to k. So let's try and answer solve this. How much time do we have left? Not possible, not solvable at all. This one. But this gives us lot of hint that I think this is solvable this way. So for coefficient of x to the power I is equals to 0, then the coefficient will be minus 1. So I don't think I will go over here. Let's not because 2 of n comma I times of n minus 1 comma I modular int of k minus 1 comma I times place k. So the value will be minus I plus 1. So x minus I plus 1 comma n comma 1 is only 1 n, right? So we don't even need this somehow. Times power of modular int of k comma x minus I plus 1. I think this is it. Minus 1. Okay. Okay, so finished round. Let's just stop for now.